Okay, and next up is Nadiia, who is going to talk about the UI platform.
Hi, everyone. I'm Nadiia, as Angus said, and I'm software engineer on UI platform. Let me quickly give you an overview of what UI platform is. We're a team of engineers who work closely with design team and focuses on UI developer productivity. Our main focus is building and supporting React Components UI toolkit. And this is what I'm going to talk about today. This is a quick agenda of what I'm going to cover. So I'm going to quickly talk, kind of like give a definition of what design system is, where components library stands in design system, and then I'll walk through our component anatomy and overrides pattern. So let's define design system. There's no standard definition for design system, but we can define like main parts of it, kind of main modules. And those are, so first part of design system is design patterns. And design patterns are things, it's basically reusable elements and repeating elements and reusable solutions that combine to create interfaces. And those elements is basically like buttons, inputs, icons. The next one is perceptual patterns. Perceptual patterns is things like typography, colors, spacing, and layouts. It's basically all the things that create difference between products on the same platform. And the last but not least is shared practices. And shared practices is basically the way how those design patterns, perceptual patterns are, like how they work together to create, to serve specific purposes, like product purposes. And those can be, for example, handling big data and multitasking, or for example, thoughtful reading for other products, and or engaging in some exercise. There are also different other different patterns that included in design system, like for example, platform concepts, but we will not cover those today. So where components library stands in, what's the part of components library in that design system? Component library is basically its pattern library. It's a set of reusable building blocks. Component library shouldn't be thought as interchangeable with design system, but as a tool to make design system more effective. And component library enables us, like engineers and developers, create consistent UIs much faster. Before we go into how we build our components, let's look a little bit what didn't work with our previous component library, and like what the issue we had with it, and why we decided to create, like, to rethink the approach and create new components. So our old component library, we named it Superfine. It was originally created for marketing purposes. And since like theming, legibility, accessibility, data dense UIs weren't main goals for that library, like for that design. And, but inevitably that library started to became kind of, people started using it across all applications, across a lot of internal applications that had different purposes. So basically, if you go back to perceptual patterns, is basically this library wasn't built to serve different perceptual patterns. And as a result, we ended up with a lot of duplicated code, with a lot of duplicated components across all of our code base. So once, when we introduced, like pretty recently, when design team introduced new design language, we decided to look back like into what didn't work with our component library, and we decided to solve those issues that we have. And in order to find out like what was the biggest issue with our previous library, we set up kind of focus groups meetings to get feedback from engineers across our company to find out what are the main pain points. And across all the feedbacks that we've got, there are three main issues that stood out. And those were customizability, usability, or reusability, sorry, and themeability. So we decided it was too much work to basically redo our old component library, because like how it was built, like architecture it was just probably same amount of work as starting from the scratch. So we basically deprecated our old component library and moved with new design, new architecture for our pattern library for our new design system. And let's look into how we approach building our components in order to solve those issues. So every single component in our library, we kind of break it into distinguished like parts. And those parts are basically containers. It's stateful container, behavioral containers, then styled elements, and drop-in components. Let's look closely into every of this part of component. And we'll look into those based on the example of simple input. And this is just a component that can have some before-after elements like icons, can have some enhancers to it, or just a simple input. So as I said, we break every component into like these smaller parts, composable parts, and we export every single part of it. So basically, if developers want to use, they don't want to use drop-in components, that then they can pull basically every little part of components that we compose our drop-in component with, and they can compose their own kind of like more customizable component. So we basically export our containers, like then we export our drop-in component. It's basically, in this case, it's stateful input. And we export every single styled element is on line 5. It's basically that styled root, styled input. This is an example of behavioral container. Main purpose of behavioral container and what it does is basically it's responsible for composing styled elements and figuring out all the overrides, like what to render, what to replace. And the probably last thing, but not least, but important one, is it's responsible to pass component state, kind of component's internal state, to every single styled element. So styled elements can be styled based on kind of dynamically styled based on what component state, like in what state component currently is. And this is on line 20. You can see this shared props. So this is basically an object of props that define component state for styling purposes. And on next slide, we can see an example of those shared properties, kind of component state properties that we pass to every single styled element. And those, in this case, it's if the component is in focus state. And also, like, we use CSS and JS for styling our components. So there are like pros and cons in it, but some kind of noticeable things that you kind of can't do with, you can do directly with CSS and JS, but you can do it in a different way, is those nested selectors where you can do, oh, if my parent is focused or hovered, you can style children in like one or another way. So you do it like slightly different with CSS and JS. And for those purposes, we basically introduce this is focused kind of shared properties that we pass to every single child. So child can independently style itself based on, like, in this case, based on focus state. And we also pass like disabled, errors, size required. We don't necessarily use every single of those props in kind of default styling, but we still do pass it to every single element in order to give more flexibility for our developers. If they do need to override like something specific element based on, for example, disabled state, they can do it, even though we don't provide like distinguished style for it. Let's move to our styled elements. So styled elements is, or we call it styled components. So it's basically, I use it as a replaceable kind of styled element, styled component, because basically every our styled component renders only single HTML element. So that's why it's basically styled element. And here's like kind of schema of our input components that we use, for example, and it has some container, it has some spans for before after elements and input itself. So basically in styled elements, every single element in here is like our div span input will be separate styled component. And this is an example of our styled component. So here, since it's worth noticing is dynamic styles, that you can basically style your styled element based on those shared props that I mentioned before. So on line 7, you can see we set background based on its disabled, focused, or error state. Yeah, and on line 2, you can see like how you, basically it will be, if your styled function is, we create wrapper around Styletron styled function. Oh yeah, I haven't mentioned, we actually use Styletron for our as our CSS and JS engine. And this is basically how Styletron works. There's like styled functions that you pass element, and then a second argument, you pass a function or an object, style object. And if you pass function, so this basically styled functions that we use here, it's a wrapper around original Styletron function that will be extended with theme properties. So basically every time you use function as a second argument for styled, you'll get theme as well in its properties. And then you can reuse your theme values to style every single component. It will help, if you use it consistently, it will help, basically it provides an easy way to re-theme any of your component. Basically you just replace your theme in the provider, and then everything else will be like colors, borders, whatever you change in your theme, it will be changed based on what values you set in your main theme. This is stateful container. So stateful containers usually, they don't do much except of creating this and handling state around base component, those behavioral containers or styled elements. And the main things that worth noticing here is probably children as function that we use here, just in order to pass our state properties into every behavioral component. And then the second one is probably the most interesting is StateReducer. And this pattern is we borrowed from Downshift. And what it does is basically, it provides a way to, it kind of like provides a hook into state changes of your component. And I think on next slide, we can see like that StateReducer that you can pass in properties. It's called on every state change. And it gives you like, here's what is state type happening. Here's what we're going to set our next state to. Do you want to change it? And then customers basically, they have ability to return something else if they want to modify. Like, for example, for input, it will be, here's next values that we're going to set for uncontrolled input. And then they have ability to modify it. Like, for example, if you show not just simple values that user entered, but with some prefix, suffix, whatever. So you can modify, and then we set it as a state. And this is just an example of drop-in component. And drop-in component basically does nothing except of composing container, stateful container, and behavioral component that renders all the styled, kind of composes and rendered styled elements. This is another example of where we use render props or children as a function. We don't use it everywhere without kind of need for it. And this is an example of toast component or alert component. And for those components, you would need, for example, to dismiss your notification, you would provide some close function or whatever, dismiss function, right? And it's not always part of your component, kind of like base component, but it can be your content, something in notification content can dismiss the notification itself. Like you have button, okay, I got it, like I read it, and I want to dismiss it. So we pass, by leveraging render props, we pass the dismiss handler to children, and then you can create whatever children you want. Like you can create internal button and then assign that dismiss handler to your on-click button, for example. Let's look closely into overrides pattern that we use. As I mentioned, like it was a big problem because every product, they still need to do a lot of customizability. Like they do need to modify either some props or some styles or even replace underlying elements. So we tried to solve it to accommodate all those basically customizations. And here's some benefits that we get with our approach. And our approach provides rendering flexibility. So basically, we provide a way to replace every single underlying styled element. And also, we provide not just replacing one-to-one styled elements, but we can we kind of give an ability to replace just one element with a bunch of like HTML, so you can add some extra elements. And then this overrides approach that we're choosing doesn't pollute top-level API, so it doesn't overload it. And then the last benefit is, not last benefit, I mean, one of benefits that you get is consistency of sharing that component states that I showed previously with shared props. Looking back into our kind of DOM structure of our input component, we can see in this example, we provide overrides property that accepts, that basically, that has identifier for every single rendered element, like rendered styled element. So basically our overrides will contain that div, that container, that will, it will provide a way to override input and before, after. And we basically provide identifiers for every single element in it. And basically, how you override it. You can pass either component to replace it. For example, let's look into input container. So you can replace it with your own component that you pass in it, or you can just pass an object that has some props. You pass it as a like value of props property or styles. And basically what we do, we merge our properties with overrides properties and same with styles. And usually customers' properties and styles take precedence, or I mean like they will go after whatever we define. yeah, this is basically an example how you actually do those overrides from kind of customer side. So here's like our input component, and you provide some overrides. And in this case, we provide we override in root component, like the whole component. And in this case, as I mentioned before, we don't just like replace our div element. We still use it, but we add additional like some span element here. So we extend our markdown for this container element. And below you can see for input, we don't override input itself, but we provide some additional properties to it, like ARIA label, and then we override some styles on it. And also the cool part about it, like style overrides, you can also do with overrides, you can still do dynamic styles. So basically, if you pass a function, not an object, to your as a kind of style value, then you will get all those component state props. For example, in this case, we do get error, disable, theme, and then you can style, like provide your style overrides based on those component state. It will be dynamically basically creating styles for it. And I also put some note in here. Just for an example purpose, I put component override inline, but you shouldn't do it because it will create a new component every time it renders. So a component overrides has to be defined somewhere outside of render. This is just a quick example of, like, super simple example of overrides helpers that we get. So basically, as I mentioned before, behavioral containers, they figure out what styled element to render, and these helper functions help us to avoid a lot of code boilerplate. So it just like merges, figures out like, do I need to render default component, or do I need to grab the ones that comes from props? And today in our, I don't know actually if I mentioned the name of our new component library. And the name of our new component library is Base UI, and it's open sourced. And we have, today we have around maybe slightly more than 22 components. And yeah, it's open sourced. We have some components examples, like demos on baseui.design. Please check it out. And then it's again, third time it's open sourced, and you can find it on GitHub. As there is a short link to it, tuber.com/baseui. And we use Stateful as our CSS and JS engine. And short link to Stateful to kind of read about its documentation is tuber.com/Stateful. And the last is our feature speakers, Umka. Yeah, follow him on Instagram. Yeah, thank you so much.